Today I want to talk to you about binomial expansions. We use them a lot in physics, okay, and they're quite useful. So let's look at something like 2001 to the power 18. Okay, well first of all we take out the 2 and that becomes 2 to the 18. We take out the 1000 and that becomes 10 to the 3 times 18, and then we're left with 1 plus 1 over 2000 all to the power 18. Okay, so this is what we'll try to expand on. So the first line, so 2 to the 18 times 10 to the 54 into 1 plus, okay, we use the 18 over 1 factorial, which is easy, times 1 over 2000, and the next term then is going to be 18 times 17 over 2 factorial times 1 over 2000 all squared, plus, okay, the next term is 18 times 17 times 16 over 3 factorial times 1 over 2000 cubed. Okay, so I'm thinking that this term may be too small for the number of significant figures, and if we can see from here, 2000 squared is going to be 4 million. So let's take off some of that. So that's 2 to the 16 times 10 to the 48, and I'm going to take a million inside that. So it's going to be 4 million plus 18 times 2000, because 4 million over 2000, plus 18 times 17 over 2 factorial, which is 2 times 4000 over 4000, and then that's just it. So that's where I'm going to pause there. Let's consider the bracket then. So we've got 4 million, then 18 times 2000 is going to be 36,000, and 18 times 17 is that's effectively going to be 9. 9 times 17 is 153. So looking at it, okay, in terms of the significant figures, they got 4 0 from there. So I don't really need to think about the 153. It's not going to round up onto this one, so we can just leave it at that. So let's start again then. So 2 to the 16 is 2 to the 8 times 2 to the 8 times by, and then we're left inside here 4036153, which I just said straight away I'm going to leave like that, times 10 to the 48. Okay, so this is 256 times 256, okay, times 4036 times 10 to the, take out the 3, it leaves 51. Okay, so that's 256 all squared, which is the same as 250 plus 6 all squared, which is a much easier. 25 squared is 625, put 2 zeros on the end of it. Okay, the next term in the expansion of a square is 250 times 6 times 2, so that's 500 times 6, so that's 3000, okay, plus 36, so that leaves us with 65536. See how I've done that? It's a bit quicker than trying to work out 256 times 256. So if I'm going to do 65536 times 4036, well then I can make that, rounding up, if I'm using 4 sig figs there, I can make that a 4 and that a 0, rounding up. So if I'm multiplying those two numbers together, it's easier if I do the 4036 because there's fewer terms. So it's okay, and if you think about it, that's 65540 times 4000 times plus, okay, 9 times 4. Okay, that's going to be a lot easier for us to sort of calculate. Now, many a time you're always told to sort of multiply this and then add the zeros on at the end. Get into the habit of multiplying from the front backwards. Okay, it makes more sense. So we do 2 4 times by the 5, so that becomes 2 0 2 0 1 6. Okay, and then 1 0 1 0 1 0. Okay, we got from there, and another one. Okay, so we get that's going to be 2 6 2 1 6 1. Okay, and maybe one more. Okay, so the next step then is 6 5 5 4 0 times the 9. Okay, so we can see from this one we're going to go with so we start at the front, remember. Okay, so when we start at this front we go 5 4 4 5 4 5 3 6. Okay, and then the 0. Okay, so obviously that's 3 8 9 8 6 0, and then we do that by 4, so 5 8 9 8 6 0 times the 4. Okay, so that becomes 2 0 3 2 3 6 3 2 2 4, and so then we get 2 3 5 9 2 4. Oops, made a mistake there, so that's 4, and don't forget the 0. So 2 6 2 1 6 0 0 0 0 0, and 0 4 4 9 5 3 2. Add those two together and we get 2.64 carry 1 5 1. Okay, so we're left with that one. Okay, and that's 1 2 3 4 5 6 7 8 9. So it's 10 to the 9. Okay, add that on to the 50, so we get times 10 to the 59. No, I think that was 8. Sorry, 10 to the 8. 51 add 8 is still... Alright, it is 59. And if you work out the actual answer, that's 2.645133498 times 10 to the 59. So if you look at that, that is correct actually to 5 sig figs, which is not exactly that bad. So, okay, binomial expansions, how to use them, and also get used to multiplying from the front backwards, not the back forwards. Okay, that's a good one.